Okay, welcome to weekly number 14. This is for Math 8. What I would like you to do is to take notes on example 1 and then wait for the question that follows. Use those notes to help you on question 1. Do that for each of the 5 questions in this video. So the first example that I would like to look at is an equation. So let's review equations. 3 times the quantity x minus 5 minus 7x equals 1. Okay, so the first thing that you would want to do, if you remember back to this unit, we want to take care of any parentheses first. In this case, let's multiply or distribute the 3 to not only the x, but the negative 5. And so we'll have 3x minus 15. And then bring down your minus 7x, your equals, and your 1. If you would like to separate things with a wall, go ahead. Okay, next step. Are there variables that we can combine? Are there like terms that we can combine on either side of the equal sign? In this case, there are. We have a positive 3x. We have a negative 7x. Let's combine those terms. That would give us negative 4x. Okay, bring down the minus 15 and the equals 1. Okay, now, is there something unattached to the variable? In this case, yes. The negative 15 is not attached. We will move it by using its inverse operation and add the 15 to both sides. 15's cancel. We have negative 4x equals 16. And finally, is there something that is attached to the variable? Yes, it's negative 4. It's attached with multiplication, so we will use division. And so that will give us x equals negative 4. Okay, please stay tuned for question number 1. Okay, now let's look at number 2. I apologize that you have to write this down, but please write this down. What is the product of 1.9 times 10 to the 4th and 6.2 times 10 to the 5th expressed in scientific notation? So I'll give you a chance to write that down. Okay, first thing that we need to review is in class, we would write down the operation. What is the operation that we used? Well, in this case, the operation should all hinge on the word product. Product means to multiply. So we are going to use multiplication. Okay, so multiplication. So we will be multiplying 1.9 times 10 to the 4th by 6.2 times 10 to the 5th. Okay, with multiplication, in scientific notation, we don't have to have equal exponents. And so what we will do is we will multiply the coefficients together. 1.9 times 6.2. 1.9 times 6.2, that will give us 11.78. So 11.78. What we would have down here is 11.78 times 10 to the, and in this case, when you multiply equal bases of 10, you add the exponents. So it will be 10 to the 9. Okay, now remember, the coefficient in scientific notation must be greater than or equal to 1, but less than 10. This number is too large, so what we need to do is we need to move the decimal place 1 to the left. When we move to the left with decimals, we will count as tens. So we're going to move 10. That gives us 1.178 times 10. And we then still have times 10 to the 9. Okay, that times 10 is actually a 10 to the 1. And so now we have 1.178 times 10 to the 1 and 9 is 10. So our answer is 1.178 times 10 to the 10. Please stay tuned for question number 2. Okay, on example 3, you do not have a table, nor do you have the question. On this one, you may just want to copy down the work. I have a table with the mass of planets in the solar system. I also have a question about how many times greater is the mass of Jupiter than the mass of Earth. Write your answer in scientific notation. Okay, first of all, the key here is how many times greater. Okay, so in this question, the operation The operation is going to be division. Okay, that is the key phrase. How many times greater? So we're looking, is the mass of Jupiter, so Jupiter is right here, then the mass of Earth, which is right here. Okay, so the bigger number is Jupiter because of its exponent. It's 27. And so how many times bigger is Jupiter than Earth? Let's go with 1.89 times 10 to the 27 divided by 5.97 times 10 to the 24. And with division and exponents, you don't have to have equal exponents to divide. And so we can simply divide 1.89 by 5.97. When I divide that, I will get 0.3166. And that will be times 10 to the third. Okay, with scientific notation, the coefficient has to be greater than or equal to 1 but less than 10. In this case, it's too small. So when we move the decimal place to the right one place, we will count by tenths, with THS. And so in this case, one place will give me tenths. Okay, so that will give me 3.166 times 1/10. And it's still times 10 to the third. Okay. Now, I cannot leave a fraction in my scientific notation answer, so I'm going to bring down the 3.166, but the 1 over 10 is actually 10 to the negative first power. And then it's times 10 to the third. And now, when I multiply these bases together, keep the base and add the exponents, so I will have an answer times 10 to the second, and that is going to be 3.166 times 10 to the second. Okay, please stay tuned for question number 3. Okay, let's look at work or example for question 4. This question will be solve for x. Another equation. The equation that we have here is 10 minus 1/3 times the quantity x plus 7 equals 11. The first thing we need to do with any equation is take care of parentheses. After I bring down the 10, I will distribute the 1/3 to everything inside the parentheses. This gives me negative 1x over 3 and a negative 7 over 3. And that's equals 11. How do I get those two items with the fractions? Well, negative 1/3 times x, or x over 1. Fractions multiply straight across. That gives you negative 1x over 3. How did I get negative 7/3? Negative 1 over 3 times 7, or 7 over 1. Multiply straight across with fractions. Negative 7 over 3. Now, if you remember from class, we wanted to get denominators the same. And so what I'm going to do is I'm going to rewrite the 11 and the 10 as a fraction over 1. You can write anything as a fraction over 1. Now I would like to change their denominators to 3 so that it matches those in the middle. So that means here on the 10 I would multiply by 3, and as well as the 11 I would also multiply by 3. That will give me 30 over 3, and then I have my minus 1x over 3, my minus 7 over 3. And this would give me 33 over 3. And that is because, remember, what you do to the bottom, you also do to the top. Okay. Now that I have denominators that are equal, I can actually drop the denominators, and if you recall from class, our new equation is simply the numerator. Okay, at this point, that is supposed to be a minus 7 there. At this point, what we want to do is combine like terms. Are there terms that we can combine? Yeah, it's 30 and 7, negative 7. That will give us 23 and minus 1x, and it equals 33. We have something unattached from the variable. It's the 23. It's positive. I will subtract it. That gives me negative 1x equals 33 minus 23 is going to give us 10. Okay, and then divide everything by the negative 1. We would have x equals negative 10. Okay. At this time, please make sure that you stay tuned for the question for number 4. Okay, here is question number 5. Our question is another equation. Solve for x. And our equation is going to be 4 times 5 minus x equals 4 times x minus 1. All right, so in this equation, what we have are parentheses. Take care of those first. We would like to distribute on both sides. So 4 times 5 is 20. 4 times negative x is negative 4x equals. Distribute on the right side. 4x. And 4 times negative 1 is negative 4. Okay, can I combine like terms on the left-hand side? No. Can I combine like terms on the right-hand side? No. So the next question we ask ourselves is, are there variables on both sides? The answer is yes. So what we have learned is we try to stress move the smaller of the two variables. In this case, it's the negative 4x. Its inverse operation is addition because it's negative. And so the 4x's will cancel. We're left with 20 equals 8x minus 4. And just as a note, you could have moved the positive 4x through subtraction and still have come up with the same answer that we're going to get here. Now, do I have something unattached from the variable? The answer is yes. It's negative 4, so let's use its inverse operation of addition. And we'll add 4 to both sides. The 4's will cancel out. We are left with 24 equals 8x. And is there something attached to the variable? Yes, it's 8. It's multiplied, so let's divide. We'll divide both sides by 8. X will be equal to 3. And there is our answer for example number 5. Please stay tuned for question number 5.